So this is a full worked out example of where we're going in the chapter of a hypothesis test. Take a look up, please, or take a look at the video here. Last chapter, we heard about the mayor of Chicago announcing 45% of the city sorts correctly when it comes to separating recyclable materials from non-recyclable materials. The results of the survey said 2,350 randomly selected bins and indicated that this many were sorted correctly. So we want to test the null hypothesis. And this is where I wish I could cover up the screen and not show it to you. But what do you think the null hypothesis in this case says? We want to test. Look at how this is going to work. We want to test. What did we try to do last chapter? What were we trying to do? Estimate. We were trying to make an estimation. This time we're putting something on trial. So we will test. We want to test, and then look what I'm doing. I'm giving my null and my alternative hypotheses. Bless you. In this case, it's a proportion problem, and the claim is 45%. Fine. I might be a little skeptical, and in this case, I believe the proportion is less than 45%. It's just by accident that both of our examples today were less than on the alternative hypothesis, but it could be more than or not equal to. That's the first step of our state. And if we're going to use P in this problem, which you always have to define your parameter of interest, we have to write what P is. So same thing we did last time. P is the true population proportion of bins sorted correctly. The last thing, instead of saying what our confidence level will be, look what we're doing now. We will use a significance level of alpha equals 5%. If you want to put the little alpha down by the significance level, that's what it means. To be statistically significant means for the p-value to be lower than 5%. That's to be statistically significant. I am going to skip the plan step today because it's the exact same as the confidence intervals that we did in Chapter 8 and Chapter 7. So those aren't going away. So if you're still having a hard time with the normal condition, in this case 10 successes, 10 failures, and all that. All right, look at the do step. Everybody look at this. We will perform a one sample z, because we're dealing with proportion, z, but look, it's not z interval. What is it now? It's a z test. And if you look at your calculator, you'll see that the first 6 options are tests. Okay? So, how will this work? How will we really know if the mayor's claim is true or false? The mayor says 45%. As statisticians, we go, all right, well, let's see. I don't think it's that high. I think recycling is pretty poor in this city. So you have a bias towards being lower. Not just different from, but you suspect it might be lower because recycling higher than that is pretty hard in a big city. So we're going to perform the z-test. So what do? This right here is the sampling distribution of p hat. This is if we were to go out in the city of Chicago and get a sample of 2,000 whatever bins, we would expect about 45% of them should be sorted correctly if what the mayor is saying is true. Notice that we are assuming that the null hypothesis is the right claim until we have evidence against it. It's just like the person that's innocent until proven guilty. All right, so 45% is in the center. All right? Now, what is the standard deviation of the sampling distribution? We learned that in Chapter 7. It's this mess right here. Does everybody see that? Yeah? All right. So what are we saying? We're going to go take our sample, and here's our sample right here, 977 out of 2,350. And we're seeing how far away is that sample from 45%. I have put up, by the way, this little dotted line here, and it's 2 standard deviations below, which is about the 5% cutoff mark. Any sample that would come in below that alpha level would tell us we have evidence to reject the claim of 45%. And in this case, it's 977. So how would we figure out what this sample is compared to the 45%? This goes back to Chapter 2, a z-score. We're going to calculate a z-score just like we did back in Chapter 2. It's called a test statistic. Is that part of your thing here? Test statistic is going to be in 9.2. Okay, test statistic. So here is the test statistic in a proportion problem. This is just an example today. In a proportion problem, it's right here. Notice that it is just a z-score. We're trying to get the z level for this sample. This sample came in here, and we're trying to find out what is its z-score. So we'll do sample minus the claim. Look at this, new symbol, p sub naught. It's kind of like the claimed population proportion is 45%. That's p sub naught, new symbol. And we're going to look over all of the standard deviation of all the samples. So when I did this, everybody, I got a z-score of, look at the z-score down here. I got a z-score of negative 3.33. That is a very low z-score, okay? And if we did a normal CDF from negative infinity to this z-score of negative 3.33, you know what kind of a probability we get? You know what kind of a p-level we get? A p-level that is very, what? This p-level, this probability level is very small. It's very low. It's very low. The probability, listen, if this city really did have 45% recycling accuracy, the probability of us getting a sample of bins this low is really freakish, okay? This is giving us some pretty strong evidence that what? That the mayor's claim is not good. We're going to reject the mayor's claim. This is the deal. We have not proven anything about the mayor. We can't say we've proven you're wrong, but we have strong evidence. Our sample is our evidence against the claim. So, what conclusion would we make here, everybody? Right here, our p-level, the probability of this event occurring is 0.04%, which it's possible it could occur, but it is so low. It's lower than our significance level. It is statistically significant. So, what do we say? This p-value is low, so we reject we reject the null hypothesis. So what does that mean to reject the null hypothesis? This is what our conclude will look like. Since our p-value of 0.04 is less than our significance level, so we're saying it's less than 5%, we reject we reject the null hypothesis. So what does that mean? Here is where we talk about the alternative. So I'm going to even just type this in. So you wouldn't actually write this HA, but we would say, we have evidence to believe that the true population proportion of correctly sorted bins is less than 45%. We have evidence that the mayor's claim is true, which means we have evidence that the alternative hypothesis is to be accepted. In this case, the alternative was that it was less than 45%. Yes, Elise? Yes. Oh, shoot. Some of us have done that on our tests and quizzes. Thank you so much for helping me sort that out. I appreciate that. Okay, now, every time we make a conclusion in this chapter, we could be making a mistake, right? We say, Mayor, we've got evidence you're wrong. Now, have we proven him wrong? No. There's a possibility, 5% of the time actually, we could be making an error. And in this case, this is called, since we rejected our HO, we could be making a type 1 error. On your study guide, you could add this in, the type 1 error. A type 1 error is any time in a conclusion that you say the phrase, reject the HO. Reject the null. That's a type 1 error. So, anytime we reject our null, we might be making a type 1 error. And in this case, what a type 1 error means is we had evidence to believe that it was less than 45% sorting accuracy, but really in the city it actually might be 45%. It might actually be good, and we just got a freakish sample. That's the error in context. And what would be a consequence? What if we as statisticians were like, we've proven, like, what if we say, we've got evidence you're wrong? Then what could happen? Then the city's like, oh no, we better pay more money and up our efforts to recycle better, when the city might have been recycling just fine. A type 2 error is any time in a conclusion that your p-value ends up being pretty high, and you end up making the conclusion we fail to reject our null hypothesis. And when you fail to reject your null, then you could be making a type 2 error. Get it? Fail to reject and type 2 error go hand in hand. I'm going to let that be the end of this lesson and video. And do tonight's homework, 59 please, and bring that in for tomorrow.